Hey students, this is lesson 214, part B. Remember yesterday I showed you some ways of taking this data about heartbeats, and I showed you a couple ways of making an equation out of that, using an eyeball method and using the means method. I'm going to show you one more method here that I think you're going to like the best. That's using technology. And technology actually does a little better job most of the time of averaging out all the data so that we can get it as close to a linear relationship as possible. Now, what you're going to need to do is, if you want to follow along on a calculator, that would be great. So I'm going to start up my calculator here, and you can follow along. So I got my calculator up, and what I'm going to do is enter these data points into the calculator so that I can make a graph and use that information to come up with an equation using the calculator. So here's the important button that you have to remember. It's the stat button. You should see it highlighted in red right now. Okay, then you're going to press enter, and you get this screen that has your lists in it. And what I'm going to do is enter all my breaths per minute in L1, list 1, and to do that, just type the number and then hit enter. So there's 2 16s, I have to do them both, 19, etc. Then when I have that whole list done, I'm going to go over here and put the matching heartbeats per minute in list 2, which is L2. So 59, etc. I'm going to pause now. If you want to put all the data in, you can, and then I'll do what's next. All right, so I have all my data in, and one good check on whether or not you have it all in is look at this when you're all done. We have 16 pieces of data, so right now this is a blank spot, and I'm on the 17th one. You can tell by looking at that. And make sure that for every item in L1, you have one in L2. Then you just have to have all the numbers entered correctly in there. All right, the next thing I'm going to do is I'm going to make a graph of this, and the rest I can just put on my calculator. So I think I'll expand my calculator here. All right, so on my calculator, I'm just going to do second mode to get out of there. So I just quit. I'll leave the key press history up here so you can see when I'm pressing. All right, and to make a graph, we're going to go to stat plot, which is second y equals. And I'm just going to press enter. And it says, the first thing is highlighting blinking on or off. If I press enter there, it will have turned it on. And then the type of graph I want, and I just press the down arrow to get there. And then the lists, my X values are in L1, my Y values are in L2, and my mark, I can change that. I like this kind of mark when I'm doing this kind of a graph. There it is. Now I have to make sure my window is appropriate. So to make it look exactly like the one in your paper, I need to change my x-axis to go from 0 to actually 55, and then the scale will be every 5. My y-axis should go from 0 to 165 by 15ths. Okay, so just to get my calculator to look exactly like that. So we're going to press window now. And we're going to go from 0 to 55, and my scale is 5. And then my y is going to go from 0 to 165, and my scale is 15. Then I'm going to press graph. And let me put the large screen so you can see it. It should look a lot like the one you have in your packet, and it does. Now remember, we wanted to get an equation for this, and this is where calculators are really cool. Just press second mode to get out of there. We're going to do some calculating here. We're going to press Stat, arrow one time over to Calc, and then we're going to do number 4, which is called linear regression. And what that's going to do is it's a calculator program that estimates a line for the data that's put in there. And right now it's asking me, is all this information right? And it is all right. So we're going to go down and calculate and enter. Some calculators you can just do that. All right, so it's telling me now that the slope is about 2.22 and the y-intercept is about 22.4. So I'm going to press my y equals now and put that information in there. So slope is about 2.2 times x plus, and the y-intercept was, let me go back to that screen and see what it said there again. $22.4. So let's put 22.4 there for my y-intercept. And now, if you press graph, notice that that line goes right through, pretty much goes through those points there. And that's what we were after. So notice how that line really averages out those dots really well. So now we're going to use that equation to do a new prediction of these. So our equation was y equals 2.2x plus 22.4, and x being our breaths per minute. So if I take my 35 and plug it into there, so I'm going to do on my calculator 2.2 times 35 plus 22.4, enter, and that predicts about 100. Okay, and then we also wanted to predict what if there were 100. So I'm just going to redo this, and instead of 35 in there, I'm going to put 100. Enter. And that would predict our heartbeats to be about 242. Now, just looking at that graph here, that last prediction I made, the question says, do you think that's very accurate? What we did is we just extended this way out to 100 and predicted that we would have about 242 heartbeats per minute out there, which is way up on the y-axis. And I would say that that prediction is not very good because we are way beyond our actual data. Notice our data goes to about 40, from about 15 to 45 breaths per minute. And if I make a prediction for 100, I'm like way out of my data. That's called extrapolating, and it's not necessarily that reliable with data. If you stay within the data and make a prediction there, that's called interpolating. And that is going to be a more reliable prediction, generally speaking. All right, that's going to be it for this. I'll see you in class.